You know that famous line, space, the final frontier? It's iconic for a reason. For literally centuries, we've stared up at the night sky asking that one huge question: are we alone out here? Well, today, we're going to dive into how that question is being answered. And get this, it's not just with human eyes anymore, but with the power of artificial intelligence. We're going to do it through the lens of a classic sci-fi adventure you might just recognize.
Okay, so let's set the scene. Picture this. You are on the bridge of the USS Enterprise. Your mission is to explore strange new worlds. This quote, it just perfectly nails that feeling, right? That fundamental human curiosity that makes us want to see what's just over the next hill or the next star system.
And you know, any great adventure has to start with a mystery. And this one's a big one. The ship is silently gliding toward this enormous, swirling nebula. I mean, just a gorgeous cosmic cloud of gas and dust. But deep inside all that beautiful chaos, the sensors start pinging. They've picked up something weird. A significant gravitational anchor. So the big question on everyone's mind is, what in the world is it?
And right away, this discovery kicks off a major debate on the bridge. And it's a debate that's not just for sci-fi, it's at the very heart of science itself. What do you trust more? Your gut feeling, your trained intuition? Or do you only, and I mean only, rely on the cold, hard data? So in one corner, we have number one. She's the seasoned first officer, she's seen it all. Now the nebula is messing with the sensors, making things fuzzy, but her experience is screaming at her. She looks at the initial readings, the mass, its orbital path, where it is, and she makes an educated call. It looks like a planet. It's acting like a planet. She's pretty sure it's a planet. But then we hear from Spock. And for Spock, look and feel, that's not just not good enough. It is, well, illogical. He argues that all the radiation from the nebula could be playing tricks on them, creating a kind of cosmic mirage. He's basically saying an assumption, no matter how good it feels, is not proof. He wants data. Pure, unadulterated data. No hunches allowed.
And this just lays it out so perfectly, doesn't it? On one side, you've got number one's hunch, which is built on years of experience and just knowing what to look for. And on the other side, you've got Spock's logic, which throws all of that out and demands proof you can actually measure and verify. So, who's right? How do they settle this classic debate?
Well, they turn to technology, of course. Spock suggests they use a tool they have on board called the Exoplanet Analyzer. And here's where things get really cool. This fictional tool, it's actually based on very real technology that we are using right now to hunt for planets way, way outside our own solar system.
So what exactly is this thing they're looking for? It's called an exoplanet. Now the definition is super simple. It's just a planet that orbits a star outside of our solar system. But think about that for a second. A world orbiting a star that isn't our sun. It's totally mind-boggling. We've actually confirmed thousands of them, but let me tell you, finding every single one is an absolutely incredible scientific challenge.
And that brings us to the million-dollar question. How do you actually find them when they're so far away? I mean, you can't just point a telescope and see one. They're ridiculously tiny and faint compared to the blazing stars they orbit. So what's the secret? How do scientists actually pull it off?
Okay, so the most popular trick in the book is called the transit method. Here's how it works. A space telescope, think of NASA's Kepler or TESS, just stares at a star for a long time. It's looking for one thing, a tiny, tiny, regular dip in that star's brightness. If it sees a little dip and then another one on a regular schedule, bingo. That's a huge clue that a planet is passing in front of the star from where we're looking. That little flicker of light is everything.
But here's the catch, and it's a big one. These telescopes aren't just looking at one star. They're gathering a complete avalanche of data on hundreds of thousands of stars all at once. There is no way a human being could possibly sit there and sift through all of that noise to find those tiny, needle-in-a-haystack dips in the light. It's just impossible. And that is where our real-life exoplanet analyzer, AI, comes into play. So back on the Enterprise, you hear the ship's computer voice, initiating model with Kepler, K2, and TESS datasets. And this, right here, this is the magic moment. This is where science fiction and actual science fact just collide and become one. Why? Because Kepler, K2, and TESS, those aren't made-up names. Those are the real NASA missions that have created these gigantic archives of data from the stars. It's the very same data that our AI models today are trained on. So these missions gave us all the raw material, And now AI is giving us the superpower to crunch through it at speeds no human could ever dream of.
All right, so the AI gets to work. It's crunching the numbers, filtering out all that static from the nebula, and analyzing the light data from that mystery object. So, what does it find? Let's break down the digital verdict.
It is absolutely wild how much you can learn from this data. First, the orbital period tells us its year is super short, just 16 Earth days. Then you've got the transit depth. Remember, that's the tiny dip in starlight. That tells us the planet's size, and this one is a monster, almost twice the size of Jupiter. And its temperature? 210 Kelvin. To you and me, that's a bone-chilling minus 80 degrees Fahrenheit. So we're probably looking at a very, very cold gas giant.
And then, the bottom line. The model spits out its confidence level, 92%. Whoa. Okay, so this isn't a hunch anymore. It's not just a feeling. This is a conclusion backed up by statistics. The final classification? Confirmed exoplanet.
And of course, Spock gets the final, perfectly logical word. He admits that, yes, number one was right, but he calls her observation statistically fortunate. Classic Spock. The real win here wasn't the guess, it was the measurable data and the hardcore analysis by the AI. You could say instinct pointed them in the right direction, but it was science that actually confirmed they had arrived.
So how does this whole story connect back to the massive revolution happening in astronomy right now? Well, because this isn't just some fun what-if scenario. What we just walked through is a peek into the actual frontier of space exploration.
You see, in the world of Star Trek, AI is this essential tool, right? It's the guide that helps the crew chart a course through the unknown and make sense of data that would just completely overwhelm a person.
And here is the most exciting part of all. That's not science fiction anymore. In our world today, AI algorithms are digging through mountains of NASA data, doing the exact same thing. They're finding brand new worlds hidden in the faint light of distant stars.
And Captain Kirk's reaction just says it all, doesn't it? I'll take a 92% certainty any day. That number, 92%, it's not just a statistic, it's a green light. It's the moment a tiny dot of light in the sky officially becomes a place, a potential new world just waiting for us to explore. And that spirit is what this is all about.
So, why is this such a big deal? Why does it matter? Because AI is like hitting the fast-forward button on discovery. It's a massive accelerator. It can spot patterns and tiny signals in the data that are way too faint for any human eye to ever catch. It's taking one of humanity's oldest, most profound questions, what else is out there, and turning it from this deep philosophical mystery into a solvable data problem. Think about that. And just so you know, this whole story we've been following wasn't just pulled out of thin air. It was actually inspired by a project called A World Away. This was created by a team for the NASA Space Apps Challenge, which is this awesome global hackathon where people use NASA's real open data to build amazing things.
And all this leaves us with one final, pretty mind-blowing thought. We've gone from knowing about just a handful of exoplanets to confirming literally thousands of them, and a huge reason for that is this technology. The great adventure is far from over. So the question really isn't if we're going to find more worlds. The real question is, what kind of worlds will they be? What incredible new worlds will AI help us find next?